Two Doppler shifts in a one single echo. How do you find the frequency of the sound that catches up to the very train that made it? So this question is about the Doppler shift. So what we see in a question that a train that is moving with a constant speed u towards a cliff that is stationary in front of that. Since this the whistle is produced by the train and the train is moving with the speed u, so that's why this is our moving source. That's why I have given it a name, source moving towards observer. And in this scenario, this cliff that is in front of that, this stationary cliff is acting as an observer, which is stationary. So a sound that is traveling from a train to the cliff will bounce back from the cliff. And in this way, both will switch their roles. So in that case, in this situation, now the cliff will act as a source and the train will act as an observer. So how do you find the frequency in that case? That's what we are going to solve today. So if this is a train that is moving towards a cliff, and just suppose that this is a wave that is sent by the train, and this is a wave that is going to hit the cliff. So I'm going to show you the next position of the train, and you will see that there will be a Doppler shift in this wave. And that's why there will be a change in frequency that we are going to calculate very soon. So you see that a wave is compressed because the train is moving with a constant speed towards it. So if you want to know what is a frequency, so I am saying that this is a frequency received by an observer, which in this case is a cliff, that is equals to V over V. What we should write, because the source is moving towards the observer, so frequency should increase. So you should write negative sign here. We should subtract the two velocities, because in this case the relative velocity is V minus U into F, and according to our data booklet. Now we will write here the values according to our question. The train speed is C, so the train speed is u, and we are going to put the values. So the speed of the sound is c divided by c minus u into the frequency. This is the original frequency of the sound that is produced by the train. So this is f prime is a frequency that is received by the cliff. So another thing, look at this. I'm showing you the wavefronts, that how these wavefronts are compressed towards the observer. So this is a source. These compressed wavefronts shows us that because the distance between any two consecutive wavefront is showing a wavelength. So you see on this side the wavelength is decreasing. That is a Doppler shift, and on this side the wavelength is increasing. So this becomes when the source moves in this direction. So anyways, now in this second scenario, when the source will become observer, so I mean to say now the train is receiving a sound from the observer. So this is source now, because it is reflecting the sound wave, because sound is a wave, so it is reflected with the same speed according to the question. So the speed of the sound is c, whereas the train is still moving with the same speed u. So there will be once again another Doppler shift. And in this echo, I told you already in the beginning of the video, there will be the two Doppler shift in a single echo. So what is a frequency that is received by the train? So let's call it f prime. Okay. So now in this case, we can take a scenario of the Doppler effect in which the source is at rest and the observer is moving towards a source, because in this case this is an observer and the train is an observer and it is moving towards a source. So I'm saying it is an observer which is moving towards source. So if you remember, what is the equation mentioned in your data booklet for IB physics? So that is, this is an observed frequency or apparent frequency that is equals to V plus U. I'm going to write this addition of the two velocities, because this is a relative velocity divided by v, and here the v represents the speed of the sound, whereas the u represents, generally speaking, the speed of an observer, times the frequency uh, of the actual frequency. Now if we synchronize this equation according to our question, then dear students, this is what we need to calculate. This is the frequency f double prime, which is received by the train, is equals to, the v is the speed of the sound, that is c according to the question, plus u divided by c into this f is a frequency of this sound, which is, if you remember, it's a f prime, which we have seen in a previous case. So let's plug the value of f prime here, and we will get finally the expression that is required. So c plus u over c into f prime. Now the f prime was, if you remember, is c over c minus u times the f. The f is the actual frequency of the sound whistle that is produced by the train. And you can see that the c and this c is cancelled out. And finally, the option A is the right answer for this past paper question about the Doppler effect.